The internet is rapidly changing the way we own things, and this creates unprecedented opportunities along the way. If digital currencies brought that change to the way we own money, OriginTrail is bringing the same shift for all things physical and digital. Using the same knowledge graph technology Google used to organize information and blockchain tech powering Bitcoin and other cryptocurrencies, OriginTrail is organizing humanity's most important Web3 assets, making them discoverable, verifiable, and valuable. The tech brings anything you own into the next generation internet. Your NFT, your car, even that rare bottle of whiskey. All these assets waiting to be supercharged so you can benefit from the next generation internet economy. Join us in building the future of ownership and independence. Let's bring your assets to Web3. OriginTrail.io.
Was hidden behind it. It's going to take a while. It's working. So it's a great pleasure of mine to introduce Branimir Rakic from my neck of the woods. He's the founder, one of the founders and chief technology officers at Trace Labs, core developers of the OriginTrail protocol for trusted supply chain management. So without further ado, I'm going to let him talk. So we have 30 minutes total, including Q&A.
Thank you.
Thanks.
Thank you, Violetta. Okay, I'll try and see if you guys can hear me like this. I suppose yes. All right, so I'm going to try and squeeze in a lot of stuff in this 30 minutes. So I hope it's not going to be too much. And just one sec, sharing the screen should work. Share screen. This one. All right, it's visible. So I got about 20-ish slides. And yeah, I'm going to be speaking about Web3 asset graphs. So very brief question for everybody. I'm sure everybody's very familiar with knowledge graphs, but like how many of you, let's say, have used blockchain, have sent a blockchain transaction by a show of hands? Okay, 2, cool, 3, nice, okay. Okay, so maybe I explain a little bit more about blockchain, just more than I intended, because I intended to devote like half a slide to it. So all right, let's start with the overall agenda, what I want to be speaking today. So I'm going to speak a little bit about OriginTrail as an intro. I'm going to tell you about these Web3 asset graphs and what they are under the hood. So yesterday, if you were at our talk, you heard a little bit of a high-level story explaining what we really mean and where we want to go with them and what really Web3 is. I'll touch on that as well. But today we're going to go technical, under the hood, as much as we can for these 30 minutes. I'm going to do a very simple one-on-one demo, just so you can see like how this can be done. And basically, I hope we'll have some time for Q&A. If we don't, I'm here for the next couple of days, so you can bug me as much as you want. All right, so what is OriginTrail? Our mission is to organize humanity's most important assets and make them discoverable, verifiable, and valuable. You might have seen that in the video. And when we talk about assets, I'm going to try and explain what we mean there, but generally we think of that as in the broadest possible sense, what an asset is. Both physical and digital. And in that sense, we're very excited about Web3. However, we're not as excited as maybe your usual NFT person who is going to be pitching you like a picture of something and then that being like the $300 million worth thing or whatever. So I'm not going to be pitching that here today. However, like I told somebody today, I'm also not on the opposite side of the spectrum, so not like super cynical dismissing the idea. I actually think NFTs are a very cool tool. It's just that we're seeing like a very, very rudimentary first implementation of that, which is driven by maybe not the best intentions or qualities in people, like greed or something. However, they're a cool tool, so I'll try and touch upon that today. So what is OriginTrail? Well, we believe that it's the world's first decentralized knowledge graph. Not sure, we don't really care that much if it's the first, but it is a decentralized knowledge graph. And essentially, this is how it kind of very high level, it looks like a three-layered architecture. So on top of obviously sitting are applications, and we've labeled them as Web3 applications because of the two layers underneath, which are layer 2, the decentralized knowledge graph, and layer 1, which is blockchains, multiple. And that's why it says multi-chain consensus. And very briefly, it is really a decentralized semantic network that synergizes knowledge graphs and blockchains. It is a multi-chain graph, and currently, OriginTrail is running since 2018 late in production in the mainnet, and it has over 2,000 nodes globally. What does this mean? Well, that means anybody can run an OriginTrail node. There's no central authority controlling the network. There's no admin. There's no admin key. There's just the admin is actually, in a way, the blockchain. It has an encoded protocol there that regulates how these nodes work together. Some of them actually get even rewarded if they do a good thing for the system, and punished if they don't if they do a bad thing for the system. Yeah, there's a bunch of people, actually quite a lot of them in the US, running these nodes in the cloud, and this is all open source, obviously, and free. And currently, we're launching the version 6. So we iterated quite a lot over the last couple of years, made mistakes, we learned a lot, and well, I'm going to be showing you a little bit of this version 6 today and explaining how it works. So just briefly, as I mentioned on blockchains, the idea there is how we observe blockchains is not like they're not going to change your washing machine and you know, be a babysitter or whatever, as people commonly or often try to like overemphasize their influence. However, they're really cool tools. And we believe that the best way to sort of label them is trust networks, that they are really trust networks. In that sense, if we try to explain that, we see them as decentralized stateful protocols. So as opposed to, let's say, an HTTP, which is stateless, blockchains are actually usually implement stateful protocols that enable this verifiable shared state. That's the cool thing. And I think a lot of people maybe miss that because this word protocol is kind of like what we're used to in the sense of, well, HTTP and all of the other ones. So when we get this verifiable shared state, what we get is kind of like a common database, let's say, which we are all able to somehow interact with. And that gives us the ability to build a tamper-proof shared ledger, but also a couple of other cool things that have kind of emerged over the last couple of years. For example, decentralized identity. That's a really cool one, and we actually use quite a lot of that. There's a standard in W3C called decentralized identity, or DIDs. Asset tokenization, or NFTs, like I said. It's not just monkeys. There's other things as well. But the whole point here is that you're able to actually create an ownable identifier, an ownable token, kind of like an ownable domain name. But rather than you buying it from some authority and then essentially renting it from that authority, you're actually really the owner of that particular, whatever that NFT represents. Decentralized finance has been all the rage. I'm sure you at least got a whiff of that. And but really what it is also capable of is this trusted multi-party computation. We can write some code, we can all review it, we can put it on a blockchain, and then we can all see if that thing was really triggered by some input, and if when it executes, it's going to execute exactly as we, whoever that we are, wrote that particular piece of, well, code that computes for whatever we want. So essentially, blockchains are great for trust. You can write some code, you're going to be able to trust that this is really going to execute if you sort of trigger it the right way, you send the right transaction, and then these are a couple of things that have kind of emerged as very useful as in terms of tools for blockchains. But what they're not is they're not really good databases. So if you try to use a blockchain today, you're going to have a really hard time querying something. Like even the other day, I tried to, like, for example, there's this notion of wallets in the blockchain, which are really addresses. So like you can create one in a second. I can show you right after this, like very easily. And it's really a combination of private public key. So if, let's say, I have some, whatever, ether or tokens or whatever, I can send it to your wallet if you just give me your public key. And because you have this private key, it's kind of like a password for your wallet. You're able to send that further, sell it, do whatever you want with it. or run a smart contract. But if you want to see who owns which NFT, for example, you're going to have to index that somehow outside of the blockchain. That's actually not doable directly from the blockchain. You can query some things, but essentially you're not able to write a query as we here know it, like a Sparkle query, a SQL query. That doesn't exist. So what I like to say always is that blockchain is not really great for data. It's great for these things up there, like, you know, if you want to have some NFT or you want to trade some tokens, which are relatively simple contracts. You can kind of compare them even to like a calculator style type of a thing, but it's a really trusted calculator, which is useful. However, it's not a database. And then, so in blockchain being trust networks, we relate that to knowledge graphs being semantic networks. And since we're at the Knowledge Graph conference, I'm sure I should not be spending a lot of time on this slide. But this is my usual slide, which I try to explain to people that it's about things and not strings, or the band, which was strings, not things, right? Anyhow, a couple of organizations that use it. So when I explain this to blockchain folk, where we often go to conferences, I need to explain to them that this actually exists. They don't know about knowledge graphs. But you guys do, so I'm not going to stay here. But essentially, we have these trust networks and we have these semantic networks. And when you think about the terms and this whole Web3, Web3 today, everybody sort of relates to decentralization, but like I just want to really quickly reiterate the talk from yesterday. Web 1, people see as kind of this read web. You have some very simple documents websites. You cannot really write on like a comment on a blog post or post on Twitter or something. In Web 2, you could, but like in Web 3, you can actually own a piece of that. Maybe you can own a Twitter profile. Maybe you can own a picture or something. And this, obviously, this own is a little bit of a tricky thing to position. Like, what does that mean? Do I really own a picture if somebody can right-click save as? Very valid questions. So I'm going to try and explain what we mean with own and why we believe the Web3 is going to bring a new primitive, essentially these new assets into existence and are going to unlock a lot of value. But essentially, people think of Web3 today as this. However, I'm sure there's somebody in this room who has heard about the term Web 3.0 before, quite a while before, from who? Semantic Web, Tim Berners-Lee, exactly. And he talked about the web of meaning, and which we believe, at least at Trace Labs, core developers of OriginTrail, is still a very valid vision. Had probably took some time to get its form, but also, and probably had a little bit of a, you know, rumbly road. But we believe that today we're going to be looking at the semantic Web3, which is a combination of that semantic web and Web3. And actually, the Web3 enables some of the original vision of the semantic web, particularly in the upper layers. If you look at that stack that Tim Berners-Lee wrote, like everything starting from XML and RDF and building up and going into the final layers of trust and proof, well, this kind of helps in that regard, all of these trust networks, right? Not to stay here too much at theory, anyhow, we're big proponents of the semantic Web3. So when I actually talk about these assets, well, we think about Web3 assets today, these things that you're able to see. Like I said, some of them may be funny, some of them might actually look useful. They're just tip of the iceberg. And we think that there's a lot of assets that we own that both are physical and digital that are not yet Web3 ready, and that is what we want to do with OriginTrail. So be that a physical object like a whiskey bottle that we actually showcased here yesterday that you might want to tokenize and then somehow sell, monetize, or is it like a digital object, like, for example, some very valuable data that you collected from a farm or whatever research you've done? We see that data as well as an asset, and you should ideally be able to own it, and that means also monetize it. So that's kind of a very quick intro. Just to give you a bit of a hint, OriginTrail is already heavily used in the industry. Yesterday, we had our partner from BSI showcasing 7 applications that we're building together with them, British Standards Institution. Most of them somehow related to assurance and compliance, but also pharmaceuticals, generally supply chain tracking, also that whiskey case. We also work with the Swiss Railway Company on their supply chain transparency. We have, I think, 4 applications with them, a bunch of others, a bunch of also projects that are in more of a prototype POC phase, but essentially a lot of this is running in production already. Not going to go deep into it. If you're interested, a lot of that is on the website. And essentially, what can you do with it? Very high level, you can build with semantic high quality verifiable data. This verifiable I'll explain soon. You can publish verifiable claims from any system, integrate all of this data across the Web3, as in the integration sense of knowledge graphs. You can build privacy first metaverse ready dApps. We have metaverse, cool, another keyword. You can discover and crowdsource high quality data sets and then tokenize your assets, ideally dynamic assets. So I'll try to explain some of that in more technical detail in the remaining 13 minutes I have. So I'll try to hurry up. Under the hood, how does that look like now? It all sounds very nice, but like, how do we actually build it? So this is a very high level diagram that depicts two essentially groups of protocols. So I'm gonna try and point with my mouse, I guess you guys see it. So this first red box on top, these are like these indexing querying protocols, which are used between parties, whoever the data consumer is and the data provider, to actually facilitate this discovery. Think of it as like your Google search for some assets. So when you go to Google, you type in whatever knowledge graph conference, you get a bunch of pages as a result, right? So that's like you're finding something, you're discovering. And then somebody had to index that before. So, well, Google did it, obviously. So anyhow, you kind of get this interaction first. And then you pick a link. Maybe the third result is what you like the most. When you click on that, that's actually the equivalent of this data exchange protocols below. So you initiate with the actual resource that's behind that link, right? The website, for example. So similarly in the DKG, you have the public DKG, which is hosted on this ODN, OriginTrail Decentralized Network. Like I said, 2,000 plus nodes currently. And you have some interface that you interact through it with the network. Currently, that's either a client, like an SDK, or a light node. I won't go too much into the light nodes. You can also have a full node as well. But essentially, either you have some node, which are part of the network, or you have a client that connects to a node that speaks with the network. And then that means you can publish something. So you have these publish protocols, which allows you to index something in the graph. You can query something, find whatever's been indexed at certain keywords. And then when you find it, you're actually able to exchange, to initiate this data exchange. Now this below doesn't necessarily have to be decentralized. Maybe like, for example, I discover something that's on the OntoText platform and I initiate the direct communication with the OntoText platform, and perhaps I use a token to pay for certain data assets that are in the OntoText platform that the OntoText team or whoever's using it wants to monetize. So hopefully that paints a little bit of a picture. You kind of find something, then you can interact with it, potentially pay for it, and so on. And then conceptually, the architecture looks a little bit like this, so try to be faster. So we have the applications on top. We have some services. Think of it as more of a kind of a lower level, less UI-like applications. And then we have this data layer, which is really the graph, the knowledge graph, which is decentralized, hosted on this network layer of, as I mentioned already a couple of times, a couple of thousand nodes. And then at the bottom, there's what we call the consensus layer, which is actually a bunch of blockchains. Why is it a bunch of blockchains? Well, because first of all, we don't want to lock people into one specific blockchain. We're not the most clever people in the world to know for, I don't know, which blockchain is the best. We do know a lot about them though, and we have implemented currently OriginTrail on 3 blockchains. That's Ethereum, Gnosis, and Polygon. And very soon we are going to be launching our own custom-made blockchain for the decentralized knowledge graph on Polkadot. It's going to be called OriginTrail Parachain. The idea is also to enable others as well, but actually this idea lives on all of the layers. So each of those, the network layer, for example, or the data layer, you'll see a couple of databases there. Probably some of you know them, like GraphDB or Neo4j or BlazeGraph. The idea there is that you want to use OriginTrail, you want to run a node. Okay, pick your database, take GraphDB. Then you want to use Polygon blockchain. Okay, pick that. And you're able to sort of assemble the component of the system as you wish. But the point is that, and that is also one of the principles of OriginTrail is actually neutrality. We're building a neutral open source system that anybody can use. It's also inclusive. And then finally, we're focusing also on usability. So we're trying to make this as usable as possible to as many people as possible. So this is a really high-level conceptual architecture. Think of a network sitting, it's not a blockchain, again, with blockchains have their own constraints, but like we have a network that hosts the graph. Now, how does it actually host the graph? Well, each of these nodes in the network has its own graph database, which can be one of the ones that are over there, probably some more in the future. Actually, I think we miss Apache Jena, I guess is how you pronounce it. That's how we say it in Serbian. Anyhow, each of them hosts a piece of that graph, and actually the data gets somehow cleverly dispersed around these nodes, which I'll explain in a second. As I mentioned, we're launching a custom blockchain, so I encourage you to look into that because it's going to be very interesting. We're going to build something called graph contracts, which are specially tailored smart contracts for, well, obviously graphs. So think of triples being the core data model, well, basically the primitive of these graphs. Okay, so the DKG is really a stateful graph index. Essentially, the network hosts the graph, and it utilizes techniques like content addressing, replication, peer-to-peer communication. So whenever you replicate something on the network, it actually knows where something should go, right? It does that by actually using the principles of content addressing. Have you heard of content addressing by a show of hands before? Okay, some people, cool. If for those of you who do not know about it, think of your network being like a street, a very long street, and every house on that street has a number. And then you can also take data and you can give it numbers as well. So let's say you have a row of houses and then you have a row of boxes of data. And then when you have a data box that somehow gets labeled by number 36, you put it close to the house that is closest to the number 36. That's kind of the idea of content addressing. You're kind of you're putting the content at a certain place in the network or the street, whatever, in this analogy, so that later you're going to be able to find it the same way. So actually, this is really cool because the larger the network grows, actually logarithmically, you have the growth of this indexing algorithm. So it's actually very efficient. You're able to find things on the network very quickly, and once you find it, you're able to query it. So I hope that explains it a little bit more. Replication is obviously used so that we have a certain level of decentralization in the system, so that there's not, because any node can disappear at any moment, right? They're actually incentivized so they don't, but like each of the nodes in the network hosts a piece of the data actually determined by this content addressing. So if I'm running a node and it's at location 36, it's going to naturally get some of the stuff to be hosted, which actually the publishers who put this data into the graph pay a fee for. So again, they don't pay like some SaaS system to host the data. They actually pay the nodes in the network who host this data by locking up some tokens in a smart contract. And this is called a trace token. This is the native token of the OriginTrail decentralized knowledge graph, that layer 2. And basically publishers compensate the ones who host the data. If some node runs out of the system for some reason, gets shut down, there's other nodes that are hosting the same data because the data has been replicated. And because they are able to claim this reward in tokens only if they can prove that they really hosted data to the smart contract, now we have a closed system. So there's actually the blockchain is used to verify that, indeed the protocol works. As actually the smart contracts on the blockchain are kind of like a judge. They make sure that everybody who should get paid, they get paid, right? So combining these records from the DKG and the blockchain, we actually get these Web3 asset graphs. And I'm going to try to explain them very briefly. So it's actually a Web3 asset graph is kind of like a verifiable data asset that you own. And more specifically is, let's call this a formal definition. I'll give it out here, but like think of it as like a digital twin, or more like your social media profile. It's a bundle of data that currently you don't own on Twitter, right? It's kind of, you can post there, but like they own it. Or any digital asset, like whatever, PDF. And like I said, formal definition would be that it's a unique digital asset that lives in the DKG and has an associated blockchain, and it has a unique identifier, something we call the UAI or UAL, unique asset, uniform asset identifier locator, has a semantic representation, naturally, graph, has some state verifiability proofs, so you can actually verify that a certain state is valid. I'll explain in a second. Has ownership, as in any asset in the world, has ownership, and then optionally has an associated token pool. That's a little bit wider for today. Obviously, I used up most of my time, so I'm gonna just rush through the rest. And I guess we leave the QA for outside and for drinks. Very briefly, what do these UAIs, UALs look like? Well, we didn't reinvent the wheel. They're pretty much according to the URI scheme. So I'm just gonna quickly skip through that. So you know this is the common scheme, right? Well, this is how the UAI has, actually UAL looks like. It has something called a DID. This is actually a decentralized identifier, and pretty much, well, it conforms to the usual scheme. The basic idea is that with this UAL, you can resolve the asset state graph. So whatever that Web3 asset is, maybe your data set, you're able to like go to this UAL and you get the latest verifiable state. So an example would be something like this. It doesn't look so beautiful because this is like a non-human readable version of it. There's also a human readable version of it that you get, like kind of like a nice domain name versus an IP address. And this is the thing we're building in this new version of OriginTrail, version 6. So essentially, if you heard about DIDs, very briefly, this is kind of an extension of DID URLs. So URLs are DID URLs. Real world assets are actually DID subjects. The graph is actually a DID document. The asset owner is the DID controller. So if you're interested in like really diving deep into the standard, I suggest you jump into W3C decentralized identifiers, and it's very well explained there. And essentially, the DKG in this case is the verifiable data registry that's used to share this common state. So how can we create them? Well, usually you kind of heard probably of this CRUD, create, read, update, delete acronym. Well, we have something very similar. It's called CRUT, which is create, read, update, and transfer. So if you want to create an asset in the DKG, you would do something like this. In, for example, JavaScript, dkg.assets.create. You put some content, which is really a JSON LD, and then some options like keywords, visibility, and so on, because just to stress out, not everything has to be public here. Then you can get them, obviously, update, and transfer. And transfer is actually very cool. This is this property we get from blockchain. I'm able to create an asset, which is like a graph, and because I own it, I'm able to update the state. And as soon as I decide I maybe want to sell that, like let's say, again, imagine, I think the easiest one is, think of a Twitter profile. Maybe you want to sell it. You can sell it to somebody. It's like giving your password away to somebody, and then they take control of that state of that graph, right? So each update is actually an assertion, and they're based on verifiable credentials. Another W3C standard. Totally recommend you to check it out. But think of it as a signed JSON LD object. They're natively RDF based, so they have a bunch of metadata for indexing, obviously the asset state and data. And verifiability is implemented using graph Merkle proofs. So essentially, you have a graph, you can compute one hash out of it, and then you can claim that a certain triple is part of that graph without having to actually share the whole graph with anybody. So think of a very large graph, like, I don't know, gigabyte of data, but I want to prove to you that I have these two triples inside of there. I can do that very efficiently with graph Merkle proofs because they're super efficient hashing structures. And think of these assertions really as Git commits. So you have like a file, and you constantly update it, and you make commits. Well, basically, you commit to a new asset state. So they're like different states of the graph, and they're all timestamped. They all have basically this hash on the blockchain, and all of them you can verify the issuer of, and you can verify obviously the time of issuance on the blockchain. So how can you interface with the DKG? You can use the SDK. I wanted to show you one, but I guess we'll have to do that outside if you want to see, or the DKG nodes. There's no centralized service. Like, you don't have like a global Sparkle endpoint. You can have your own by running a node and then use that as a Sparkle endpoint into the network. And for example, you can even use it on a blockchain. So you can query and publish assets to the DKG, and then you can put them in the blockchain and use that as your source of, let's say, data for a smart contract. So maybe you want to execute an action based on some verifiable certificate that was issued by, let's say, the British Standards Institution, and because it's a graph that your blockchain can understand, you can actually put it in a smart contract. So in very high level summary, you have the DKG, you have some blockchains, you have the SDK, and you have your application that interacts with this graph. And then on the DKG, you actually have these asset graphs, and on the blockchain, you have two things. You have these state commits of assertions, as I mentioned, and you have this token, which is actually an NFT, happens to be an NFT, that actually connects to that graph and contains that UAL. That's how you get this transferability. So you're able to have your data set, which is very valuable, you're able to send it to somebody, and then from that moment on, they're able to update the state, if that gives you a little bit more context. Unfortunately, I overplanned with my slides. I wanted to show you a very brief demo, but we don't have time for that. So can I have 30 more seconds? Yeah, sorry, Ruben. I'm jumping over another slide. I just wanted to thank you for the attention and yeah, ask you if you want to know more. I'm out here for the next couple of days. Feel free to ask. And yeah, thank you for the attention again. Cheers.
The internet is rapidly changing the way we own things, and this creates unprecedented opportunities along the way. If digital currencies brought that change to the way we own money, OriginTrail is bringing the same shift for all things physical and digital. Using the same knowledge graph technology Google used to organize information and blockchain tech powering Bitcoin and other cryptocurrencies, OriginTrail is organizing humanity's most important Web3 assets, making them discoverable, verifiable, and valuable. The tech brings anything you own into the next generation internet. Your NFT, your car, even that rare bottle of whiskey. All these assets waiting to be supercharged so you can benefit from the next generation internet economy. Join us in building the future of ownership and independence. Let's bring your assets to Web3. OriginTrail.io.